Okay, so in this video, I am going to be talking about polarized beam splitters. As you can see on the diagram here, the transmitted beam continues on straight while the reflected beam exits out the left side. And if we use a camera to take a closer look at the cube here, we can actually start to see sort of a crosshair shape take place. This is showing the transmitted beam and the reflected beam. And I thought this was interesting because this is even at a relatively low power level of just 10 milliwatts and with the lights turned on. Now, on their own, a polarized beam splitter is not particularly useful for creating holograms. The reason for that is that the two beams have opposite polarization. Fortunately, however, we are able to fix that by introducing a half-wave plate on the output side, either on the transmitted or the reflected beam. And to make it even more useful for creating holograms, we can add another half-wave plate on the input side leading up to the polarized beam splitter. And so I will be going over that in more detail in just a moment, but for now you can see how this device can be used to create both the reference beam and the object beam. So this is the reflected beam and this is the transmitted beam. The reflected beam has S polarization and the transmitted beam has P polarization. Now what you're looking at here is very minimal, in fact almost no fringe contrast. And the reason for that is that both beams have opposite polarization. When we are creating a hologram, we want both beams to have the same polarization so that we can maximize the fringe contrast. Now, what I've done here is I have inserted a half-wave plate on one of the two beams. This is on the reflected beam, and at 0 degrees, it does absolutely nothing. It does not change the polarization at all. So that is why we currently have minimal fringe contrast. Now, as I start to adjust the half-wave plate towards 45 degrees, then we start to see an improvement in the fringe contrast. So as I focus the camera here, you can start to see that improvement in the fringe contrast. So that is at 20 degrees, and then as I continue to adjust the half-wave plate towards 45 degrees, then we continue to see an improvement in the fringe contrast. And again, this is exactly what we want when we are creating a hologram, is to have the maximum fringe contrast. Now, I mentioned before about having two half-wave plates, one on the input side of the polarized beam splitter and one on the output side. So this is on the output side. The reason to have one on the input side is so that we can adjust the beam ratio. And I will go into more detail on that in a subsequent video. And again, as I adjust this half-wave plate on the output back towards 0 degrees, we'll start to see the reduction in fringe contrast. Because once again, the reflected beam now reverts back to S polarization, which is the opposite of the transmitted beam P polarization. So that's about it for this video. Thank you for watching and see you next time.